Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
I'm one of the two architects that owns the Indigo programming model here at Microsoft, and I'm speaking with Dr. Khan. You're lucky today to have two Ohio State people speaking to you. I'm graduated in 1979, and he's an illustrious faculty member of my alma mater. Yeah, and so what's going to happen here is that I'm going to talk to you for about half the talk about Indigo's ideas, the architecture of the system, the big ideas you need to understand, why we built it. I'm going to show you some code just to give you a feel for the basic features. And then Dr. Khan is going to show you, he's one of the people who's been working with us since the get-go on a very interesting project using Indigo at Ohio State. So here's the breakdown, two parts. I'm going to give you a little bit of talk about why we built Indigo, what the big goals were. I'm going to talk about the structure of Indigo, and so on. When we built Indigo, we had three things in mind. We had productivity goals. The current state of practice in the building of distributed applications involves lots of different products, and we wanted to simplify things, make it easier for people to build a wide range of applications with one OM. We had interoperability goals. The state of play of wire protocols is pretty complicated in the space. Because we don't believe we're done with software innovation yet in the space of distributed apps, rather than standardizing around software OMs, we're advocating standardizing around protocols. And so a big part of Indigo is to make that possible. And finally, Indigo is based firmly on top of service orientation. Service orientation I'll talk about in a second. Oops. So if you look at the state of play of the major stacks being used today to build distributed applications, both the Microsoft.NET stacks and the Java stacks are fragmented. And every single different kind of thing you might want to do involves building a different OM. If you want to do durable messaging, you use JMS or our system.messaging stack. If you want to do transacted, business-oriented container things, you use Microsoft's Enterprise Services or EJB and so on. So a whole variety of things. What developers end up having to do is to build, is to choose a particular technology or two to become expert on, and then they're trapped into the patterns, the technologies, and the protocols that that particular OM is using. What Indigo is all about is to smooth all that out. It's a single programming model which on our stack will replace all the existing stacks. So if you want to do messaging, RPC, web services, local programming, any of the current things that you use in all these different stacks, Indigo is the next pattern. We're taking all the good features of all these products forward into Indigo. It's the next version of all these things. We won't be developing the other products anymore. And out into the future, Indigo is the platform we'll be using for all these scenarios. Indigo builds upon a rich history of XML protocols. And so while we tend to think of XML protocols as useful only in web services, in fact, Indigo speaks these protocols in both binary formats with TCP, text formats with HTTP, and so on. Indigo is profoundly based on top of SOAP and XML, although it works equally well with REST or POX kind of strategies where you're just downloading documents with no headers. But the fact that we have the headers to work with lets us do things like security, reliable messaging, and transactions as headers on top of the SOAP envelope. So Indigo is not wired down to any particular protocol set. We're very flexible, and we can evolve to handle any protocol that comes our way. We can do everything from very, very simple XML exchange to very complex conversation-based security and reliable messaging. And it all works well in the Indigo architecture. But we're very committed to the set of standards that are arising on top of WS security, WS reliable messaging, and WS transactions, merely because they allow us and our partners to test a single set of protocols that give us this rich feature set. And so the attraction of those is going to be more that there is a clearly tested spot. We don't imagine they'll be stable forever, they'll evolve. And so we've architected Indigo to support that evolution, sticking all the time to the set of protocols that are actually giving us interop, so that we can avoid lock-in at vendors, at sites, and also so that we can avoid the tremendous cost of integration that most businesses face. When I started programming in the 70s, and so when I was programming, the lessons I was hearing debated in the world is whether we could ever deal with the performance hit of getting rid of go-tos and common blocks. And generally speaking, while a lot of arguments in the computer science field, especially in practice, boil down to a question of this is good and that's good, but we're arguing about it, it's been a successful thing to argue against coupling. So over the years, what we've seen is that applications have got larger and larger. I use I use structured programming to decouple the lines on a screen full of text. And then I used objects to manage coupling within an XE. I used components to manage coupling in a set of XEs that had pluggable modules. Service orientation is nothing other than a set of principles that manage coupling in distributed apps. Service orientation is the thing I understand best, and I'll define everything from services to web services and all the other words that are in this space based on service orientation. It's a programmer discipline. Indigo isn't necessary for service orientation any more than you needed C++ to do object-style coding back 20 years ago. But Indigo is definitely built such that it's natural to fall into service-oriented patterns, in the same way as it was natural to fall into object-oriented patterns using C++. So Indigo is about making it easy for the average programmer to build decoupled modules in a distributed system. Talked about why we built Indigo. Now I'm going to talk to you about the structure of Indigo. And this has two parts. I'm first going to talk about the key ideas in Indigo, the things that you need to understand in order to make sense of the code or to understand how the system works. And then I'll give you a few slides on the architecture of Indigo. The key idea in Indigo is an endpoint. Endpoints are related to services in Indigo the same way that interfaces are related to classes in an object-oriented space. So a service to run goes ahead and publishes the intent to listen on a set of endpoints. The service completely defines the endpoints. Then clients go ahead and pick an endpoint, build a conformance stack on their side, and begin communicating. So communication always happens between a pair of conformant endpoints. The service defines endpoints and listens on them passively, and the client picks an endpoint and starts communicating. Indigo is fundamentally a message-based system. We simulate RPC by correlating messages, but Indigo is inherently a unidirectional messaging system. That gives us obviously the most flexibility in scaling up to more complex patterns. Endpoints are made up of three things, and we actually came up with this before the marketers got excited that this is the ABCs of Indigo. But every endpoint has an address, which is where it lives in the network space, a binding, which completely describes how the endpoint works, the transports, the encoding, and the protocols that the endpoint understands, and the contract, which describes a set of operations and schemas that the endpoint speaks. The key thing here is the distinction between contract and binding. If you're programming on most of today's platforms, you make a commitment as to how you represent your contract, and you're kind of locked into binding space. Or alternatively, it's very difficult to build an application that can implement a contract without caring about its binding. In Indigo, the developer builds contracts. The developer has an API that lets them build the contract without any knowledge of the underlying binding. Then when I go to deploy an Indigo app, I configure endpoints and associate them with bindings. And so it's a simple matter of reconfiguration to go from one transport to another, to go from a text encoding to a binary encoding, to go from an application reading XML directly off the web to reading XML in a SOAP message, to go from using Windows security to Kerberos security to federated security using some of the extreme protocols. These are all matters of reconfiguration. It's tremendously beneficial from a use case point of view because it allows businesses to deploy apps without locking themselves into things so that a change in deployment requirements needs a recompilation. It's also incredibly valuable because it lets us be very extensible about transport and protocol at the lower level of the system in the binding without having to worry about modifications to the programming model. So as you'll see when we look at the architecture, there's a tremendous flexibility in being able to implement new transports, new encodings, new protocols without changing code, application code at all. Conversely, you can code to the semantics of your binding. I need a transacted queue, or I need a reliable session. And you can do that specifying the abstract qualities you need, and the actual physical details of the transport are left for later. In addition to endpoints, there's two other important ideas in Indigo. Indigo publishes metadata. All the endpoints of an Indigo service are completely described, both their bindings and their contracts, through metadata in standard formats, WSDL and WS metadata exchange. The bindings are expressed in a set of policy assertions conforming to the protocol WS policy. And Indigo also supports the notion of behavior. These are features of the client or service that aren't necessary to know on the wire. Service-side instancing models, service-side concurrency or throttling issues, locations of credentials on a client. These can be matters of configuration or can be coded in via metadata, but they're not a thing that is needed on the wire. The client and the server don't have to agree on those things. I didn't tell you anything, by the way, but I'm delighted for you to interrupt me with questions, and especially if they're pokey, harassing questions like you think I'm giving you a load of cobblers. Feel free to challenge me here. So if you had to set up all these endpoints by hand, which you can, it would be a relatively tedious process for a simple programmer. And so Indigo has some high-level OM that makes starting a service a simple matter of writing code, then starting up a class of type service host that goes, reads your configuration, reads code, and starts up all the endpoints. On the client side, you can just new up a class that supports the methods that create messages that are sent to the server. Key thing to remember here is that the only relationship between the service and client is the contract described by the metadata. There's no necessary consistency between the types used on the service and the client. If I have a message that implements a contract, all that matters is that my contract is the same as the contract on the other side. I can come up with a new class so long as it supports the same contract, I'm fine. This gives us a lot of power both for versioning and for different helper classes that can be used in different applications to speak the same contract. Like you might imagine, Indigo being a network stack, we have a network protocol-like layering system going on. At the bottom of Indigo, the blue things here are things that are associated with the binding, and the green and yellow things are the things that are associated with the contract. So the system breaks into two layers, an underlying messaging layer associated with the binding, and a higher level programming model layer associated with the contract. Now the key thing to understand here is that all the features of Indigo are built on its own extensibility points. All the transports, all the encodings, all the protocols, all the features of the programming model. So this makes Indigo a really attractive platform for computer science research if you're interested in worrying about special protocols, talking to odd devices, doing experimentations on the optimality of binary formatters, looking at new protocols, experimenting with new programming models, building aspect-oriented code. All of the things in Indigo are just examples of what you can do with the extensibility system. The channel system can be thought of, and sometimes is described as, TCP for SOAP, TCP for XML documents. That's the way to think about it. And what that means is that the programming experience at the channel layer is exactly the same as the Berkeley socket programming model, as WinSOP. And so what happens is if a service comes up, it builds something called a listener channel. The listener channel has a method on it called accept channel, and you call that when you want to wait for an incoming session. And so a service comes up, and it calls accept channel on a listener or a listener stack, and it's sitting waiting for incoming connections. Client wants to talk to the server. The client creates a channel on the client side and calls send, and the message originally arrives at the listener, and that causes the listener to return a channel. And once the channel's returned, the client, the server code then calls receive, and out comes a message. Once this lower channel is set up, we can do more sends by sending a message directly between the channels. So like you see, it's exactly the same as Berkeley sockets. I listen for incoming connections. Then when an incoming connection comes in, I can read messages off it. To talk to it, I go ahead and create a channel that points at the right endpoint and send messages. And this can be set up either in unidirectional world, if I've got a one-way thing like a queue, or in a request-response shape, if I've got something like HTTP that's inherently request-response. Or if I'm dealing with TCP, I can set up, once the connection's going, a pure duplex communication that allows peer-to-peer messaging, using features in WSDL that aren't available in most programming stacks, where they define both in and out messages. So the channel layer, the one thing that's not showing up in this picture that would be if we were taking longer talking about it, is each of those things are actually stacks. Both the listener and the channel are stacks with a transport at the bottom, an encoder plugged in, and then one thing in the stack for each protocol. The security protocols, the reliability protocols, the transaction coordination protocols. Those are just modules sitting on the stack. If you want to build a transport that does SMTP, you replace that in the stack. If you want to build something that does your own WS secret decoder ring protocol for security, you replace that module on the stack. And the programming model is flat, so once you set things up correctly, the people who are writing the actual code have no idea what protocols you're using. That's all hidden in the details of the stack. The programming model is all about dealing with these messages through simple interfaces that understand the shape of the stacks. At the programming model layer, we have a higher order system called the dispatcher. On the client side, the programming model layer is pretty simple. It has methods that look like foo or bar or baz with regular old CLR arguments, and it translates them using a serializer into the Indigo message structure, which is then sent through the channel stack. On the server, what happens is that I have several loops over here in a pipeline. I have a loop that's waiting on the listeners for incoming connections. I loop over all those, waiting for incoming connections. When a message comes in, I call begin accept. What will happen is when that returns, there's a new channel waiting, and I can go ahead and start stacking up a set of channels. Those are the incoming sessions that my dispatcher is dealing with. And there's a second layer that goes ahead and calls begin receive and pulls messages out of those things. Now the dispatcher is being crafty. It's keeping control of the instancing model and all the dispatch correctly. So what it can do is path the messages down through a pipeline to user code. Now all the particulars of these two loops and the pipeline are also extensible. So you can stick code in there that does everything from override the instancing model to doing your own serialization, to doing your own message dispatch, to looking at messages as they go by, or looking at serialized arguments. Turns out there's 20 or 30 things you can do in this model that involve plugging code into this system or twisting knobs. So it's an incredibly extensible thing. We did that because we believe we'll build other programming models on top of this Indigo platform in the future. The Indigo programming model itself will be there, but we'll want to do things like orchestration, a variety of higher level things. And so Indigo is pluggable in all the places that will let us replace our programming model with another one. And you can see the benefit of that if you're doing research or playing around with programming models. It's a very rich platform. Now I'm going to look at some code. The rest of this talk is going to be me walking through the system and just talking about its features looking at code. That's the easiest way to make it all concrete. There are three kind of contracts in Indigo. Contracts are the things that we use to implement behavior, operations, message schemas. We have a data contract that knows about how to turn a CLR type into a schematized body of XML. Now that doesn't have to be text XML, it can be binary. You can use the encoders to turn this into arbitrary wire formats. We've already got work underway to interop with DCOM and with Corba via IOP. But the point is the data contract maps a CLR type to a schema, an XSD schema. The message contract is the thing that understands how SOAP works, how the headers work. And so if somebody wants to write code that passes data as a header so that it can be seen by the infrastructure, say an aspect, you use the message contract to poke things into headers. The service contract is the thing that actually defines the operations and methods that are used to send and receive messages, to process messages and the like. So we have messages, as schema, we have messages as header and body, and we have behavior. Those are the three kind of contracts you program with. Sure, sorry.
How would this go about?
I'm sorry, so you're asking me how this has worked out with non-Microsoft products. We're real intent on standardizing this whole space at the wire level rather than at the programming model level. Like I said, we believe that there's evolution to be had at the programming model level, so we have no intention of standardizing the Indigo programming model. Quite the contrary, that's where we're competing. What we want to do is make sure that you can move back and forth between Indigo and any other of the distributed programming models without having to sacrifice the wire. You should be able to interoperate. In addition to us going ahead and doing all the work of building our programming model, we're also busy when we build a product with a bunch of things we call basics. Security basics, where we do threat analysis and constantly worry those kind of things. Performance basics, usability basics. And we have a full-time team working on a thing we call the interoperability basic. What that means is that as the protocols make it to a certain place in the standards body, all these people go to someplace far away. They always claim it's in Kansas, but it seems like it's always in Hawaii. And there's people from IBM and BEA and Sun and all sort of other vendors that gather together, and we actually make sure that we interoperate. You know, because when you make a standard like this, it's one thing to stick to the letter of the standard. It's another to have implemented it in such a way that you're actually working. And so we have, for instance, I'm not the kind of guy to give you the exact numbers, but there's more than a dozen people that are already supporting WS security. The work is being done right now to finish out the details of reliable messaging. We're beginning the work on transactions. Many of you have probably participated in standards bodies. What we decided based on experience is that the standards that work best are the standards where 3 or 4 really smart people went off, wrote the standard, and then introduced it to the world as a starting point. So that's what we've been doing with these standards. Rather than going to a standards body and saying, let's get 150 people to start arguing about security, we've gone off with our partners and put together these standards, get them into place where they're kind of finished up, they seem like they work, we have working implementations of them all, and then take them to the standards bodies where you have this concrete working thing that can be discussed in its detail. So that's how we're doing standards, both the practice, how I'm doing it, right, making the product interop, and then the details. The biggest place we found that it's been hard to interop so far is actually in app protocols. The mapping, there's not a really clear standardly accepted mapping between 3 ints and a string in a class and an XSD. And so we're having to do a lot of work to make sure that our data contract, when it comes into a place, will actually produce a schema that then you go to a Java system on an IBM platform and it'll go back into a class that's as easy to use as 3 ints and a string. But we do all that work obsessively because the key thing for us is to get to a place where if you're using one of these products and you start a new project, you should always have the ability to pick the next project at the time. We want it to be completely pluggable and interoperable at the wire level. Now I'm too far away. So to build a data contract, what you do is you associate metadata with a CLR type. The metadata describes the contract, and the location of the metadata on the class is what maps the contract back to the actual implementation. The notion is, whenever you have a contract, it's useful to have a class you can use to program against it, but you don't want to project details of the class out to the XSD. And so these attributes are the thing that map my class, complex number, into a named contract. Now, any class in the world that supports the same name and namespace for the two doubles on this class will interoperate with this class. They'll all create the same schema, and I can use one on one side and one on the other. So I might have a very simple complex number class, and you might have one that does all sort of helper functions. The thing that's key is that our contract is just in the data we're projecting. Message contract works the same way. In addition to allow me to pick fields that are in a message body, which I can also have some of those B things that have data contracts, so it can recursively become a rich structure containing multiple layers. The target interoperable subset of XSD, if you will, is a hierarchy of name-value pairs, and you can create that here. You can also use the message header attribute to say that this particular field, even though it's in my message class, is going to be sent out as an Indigo header. And it'll be a SOAP header, and it can be intercepted by infrastructure. Why do you do that? The body is typically app to app. If I want to be routing on fields or intercepting fields with an aspect or any other sort of thing, I want to stick those arguments in the message into the header so that they can be seen as the message goes through. The body is typically streamed, so it's not read in Indigo until it's actually time for the server-side app to read it out of the transport. But the headers are all available to the infrastructure. A service contract, unlike a data contract or a message contract, is represented by an interface. And that's because service contracts are typically things that services implement. You send the class, and so you need to send a message to new up a class, set it with the right data, and send it off. But you implement one or more contract on a service. And so the natural way to represent that in a language like C# or VB or Java is to define the contract with metadata on methods. So just like data contract, the service contract is opt-in, meaning methods on the interface by default don't show up, and that's just because you don't want to leak things, and so you make the programmer explicitly say what goes out on the wire. The difference between one-way messaging and two-way messaging, request-response in Indigo, is a simple property on an attribute. The whole rest of the programming model, the security model, the reliability model, the transaction model, all the features of programming are identical. This is one of the most unique features of Indigo. Up until now, the messaging people are over here descending from the mainframe, and the request-reply people are down here coming up from their Atari 800 when they were 16, right? They're two very different cultures, and they're not in the same world. One of the big research areas that people are getting into around Indigo is trying to talk to application developers about how they choose between request-reply and messaging. We don't have pattern books that start off asking that question. We have pattern books that assume one or the other answer. I'm an object person, so I'm doing request-reply. I'm a MQ series or TIPCO person, so I'm doing messaging. And so there's a big, rich set of things to figure out how to teach your average programmer how to know which of those patterns to use. And that's opened up because Indigo makes the patterns a simple matter of changing the programming model in this very straightforward way. If I want to set up a dual communication contract so that once we get going, I can send messages to you and you can send messages to me, what I do is I define two interfaces, one that goes one way, one that goes the other. I link them with this callback contract. Then what happens is on the client, I new up a proxy that lets me talk to the service and provide an implementation that catches messages that flow back. On the service, you implement the thing that catches messages coming to you and then make a call on a proxy that sends messages back. This thing has a session in it because obviously it doesn't make sense to do dual communication unless there's a session. Indigo can natively do this kind of stuff on top of TCP and named pipes, and you can set up a special binding if both ends are addressable to use HTTP in two-way communication. But again, it's just a simple augmentation of the programming model to pick these things up. Everything else works exactly the same way. If you know WSDL, WSDL makes a special provision for things called faults, which are alternative error return schema in a case where there's an error in a request-reply message. And so we support an attribute that allows you to associate one or more faults with a service contract operation, and you just put that attribute on, and then in order to throw the fault, you just throw a thing of fault T, and T is the detail of the fault. Obviously, people doing one-way messaging don't deal with errors this way, but rather have multiple returns. One message goes back in case of a success, another goes back in case of failure. Looking ahead, you can imagine that something like an orchestration engine will become the scripting model for messaging with Indigo, right? Because that's the right way to organize the message exchange patterns at a richer level when you're building an app like this. Indigo isn't stuck in a world where you have to specify all of the message schema you understand. So here what we have is, I've got problem solver and add, which represent two different ways that I can do an addition that I know about. But suppose someone sends me some other message, and I don't know where. I can specify an action equals star and use the Indigo message, which returns the incoming message as a SOAP envelope with SOAP headers. So this is how you code in Indigo at the message level against XML. And it turns out that all the features of Indigo work there as well. So if you decide you want to do late binding or code against arbitrary documents with XML and not map them into the CLR type system, we support that at the same level that we support type programming. So you have type messaging, you have parameter signatures, and you also can code against XML. Finally, Indigo supports streaming. It turns out that all the body I/O actually happens as streams. And so what we want to do here is that we're going to go ahead and make a method call and say I want 10,000 Fibonacci numbers, and they'll all be streamed back to us as an XML stream. And what happens there is none of that is buffered by Indigo. You're just sending data back, and that can be a movie or any other sort of thing. It's supported as a first-class construct. So now we're done talking about contracts, the business of implementing your application. Let's talk a bit about bindings. Now, it turns out that in the same way as the channel stack is actually a stack of modules that's one transport, an encoder, and a bunch of protocols, just so this binding construct we talked about that's needed at deployment time is a simple way to specify a stack. And so you walk up in the world to a binding. Inside of it is an array of binding elements. And each binding element is a way of configuring a stack. And so I can have a binding here that basically deals with HTTP transport and text encoding. That's the binding I use to talk to all of today's web services. That's the standard thing being used today. If I want to go ahead and add the WS protocol so that I can do secure, reliable, and transacted messaging, that's just using a different binding, one that has more elements, elements that understand all those protocols. If I want to switch to using TCP and binary but still use the same protocols, that's yet another binding. Now the important thing to understand is I can use any of those three bindings at deployment time to expose a service. So I can choose whether I do transport security or message-based WS security. I can choose between encodings, between transports. That's all done by changing the binding that I select at deployment time. None of this is involved in code whatsoever. We ship with a bunch of standard bindings, and these standard bindings are just named hunks of configuration and stack of modules that hit most of the common use cases. So the average programmer right out of the box doesn't even need to know about binding elements. All they know is, I want to use the basic profile binding, which speaks the current basic profile. I want to do the net profile, the .NET profile for MSMQ, and I'll use one-way transacted queuing. So again, these are just named sets of configuration that make it simple to get going. And so if I want to define an address, what I do is go to a config file, which sits next to my app in a directory, and I create an endpoint. And the endpoint says what the address is. This is an address relative to a base address supported by the hosting system. I go ahead and name the binding I want to use and the contract I implemented. Very simple thing. That names an endpoint. I can define many endpoints for my service using this mechanism. This just uses the standard bindings in a simple way. Now, if I want to modify the configuration of the binding, what I do is I refer to a named hunk of binding configuration. This binding configuration is called binding 1, and it just changes the default configuration of that binding. Most shops, what they'll do is they'll name a set of configurations that they use a lot, and then those will be put away after set up by the relatively senior programmers, and then the normal deployment process will be to use a configuration appropriate to a particular use case. Obviously, this also lets you experiment if you're doing more interesting research by changing these things in config and then rerunning tests. And that's another way this is very useful in situations for doing automated tuning and the like. You can actually create a binding in config that doesn't have anything to do with our standard bindings, and you just do that by creating a custom binding and naming each binding element you want to use. So the upshot here is that a binding is just an array of binding elements. There are some standard ones. You can configure them. You can use as many as you want to create endpoints, and you can change these properties in this way. The key thing to remember is this is all happening in config. As these things get more complicated, as they take over some of the app's actual functioning, if they do things like federated security, all that stuff is being associated with your application through configuration. Final thing to talk about briefly is behaviors. Behaviors are things that can be used to assign local operational features to a service or a client when you're not actually when you don't want to have these things show up on the wire. Now, the central thing to understand about Indigo, and the thing you do mostly on the server side when you're doing behaviors, is to establish your instancing mode. Instancing mode in Indigo has 3 parts. The channel that I'm using to talk from client to server can be a sessionful channel, like a TCP session, or HTTP using WS reliable messaging sessions, or it can be a sessionless one, like normal HTTP. Obviously, if I'm doing a sessionless channel, there's not a lot of interesting instancing that can go on because all the messages just arrive at the other side. But sessions versus sessionless is one idea. Now, what happens is that Indigo uses a container model, like was invented with MTS and is used in Java Beans. And the instancing mode is actually about the container rather than the actual instance. And so I can set the instancing mode up to be per call, which means even if I have a sessionful channel because I want to have a secure conversation, I can still have the instance come and go each time so I'm not stateful. Or I can be per session, in which case I have an instance come up and live as long as the connection does, which is the normal DCOM or sort of an object-oriented view of instancing. Or I can have a session, a singleton, and that singleton means there's one context that comes up and is used to deal with all incoming messages. A print spooler, right? Now inside that, there's a third ability for the instance of the type I write to come and go to process messages. The reason the context and the instance are decoupled is it turns out in a lot of cases it's useful to spill instance state when I'm writing code. For instance, after I commit a transaction, I might have data that I use during that transaction that's locked in the database. It turns out to be a convenience to wipe that clean so when the next message comes in, I'll create a new instance. I don't have to go and delete all the data that might happen to be in the instance. Since it's often it's a common pattern to want to spill state in the middle of processing, so we have this decoupling. And this lets us, in fact, write automated tools that will go and reestablish the state from disk every time a message comes in, which lets me deal with long-running sessions and do durable state. This is all accessed through the programming model's extensibility points. So there's 2 ways of associating a behavior with an Indigo app. Some behaviors are really important to establish at development time. For instance, if I build a multi-threaded or single-threaded app, the coder is the one that needs to know that. We don't want the installer to say, oh, look, I can make this run so much better by turning on this multi-thread feature, right? You have to sort of know ahead of time, so it's associated with config. And so things like instancing mode and concurrency mode are associated with the service in configuration, or excuse me, in code. You can also establish behaviors in configuration. So for instance, I can set up a behavior here that controls throttling in a lot of ways. How many instances I'll start, how many connections I'll take, and the like. The key thing to think about is that what behaviors do is they plug in code or turn knobs on the dispatcher. You can write your own behaviors that are associated with an app through app attributes or through config, and they can go ahead and customize the path that pulls messages out of channels and shoves them into user code. So you can modify that whole space of processing by means of writing these behaviors. And all the behaviors that ship with Indigo are simply behaviors that are using our extensibility points. They can all be replaced. The challenges we face are, first, we're doing a lot of work and research to do transport and protocol extensibility. So one of the things you might do is if you're interested in transports or protocols or encoders, you might want to grab a copy of Indigo and start exploring our extensibility at this layer to see if you can start doing your own research. The second thing that we're very flexible about is programming models. Indigo is a great platform to use to program messages that are coming over standardized protocols, but where you replace and experiment with the programming model. And obviously, there's a lot of room to develop as we go forward in coming up with more and more advanced programming models that make it possible to build distributed applications in a simple way. A lot of room for that, for growth there. And third, all the things we do today with extensible pipelines can be done easily on Indigo. So if your research interest falls into any of those areas, I encourage you to download Indigo and begin playing with it. My email address is stevesw@microsoft.com. I'd be happy to talk with you about any kind of project you want to start at any time. Now, I want to pass the world over to Dr. Khan, who will show you an example of Indigo in practice. Go ahead. Does Indigo do anything to support composition of services? The answer is Indigo doesn't. Indigo right now is focused on building individual services, and what we're doing in the tooling world and with our orchestration tools is to start worrying about systems of services and being able to specify them using graphs of messages or interior, various patterns. So one of the things we're doing internally is exploring a specification of a set of patterns that services can take on, and then patterns of interrelationship. But this is something that lives, the Indigo team is working on, but Indigo is about building particular services. So a lot of the research on the protocol SOAP and then the various various protocols was done with an explicit eye towards supporting both pass-through intermediaries that ignore the headers as they go through, so as you can do security relationships between endpoints going through a firewall, or security relationships between the client and the intermediary, and then between the intermediary and the service. So you're able to encrypt headers and secure them to intermediaries while the body is encrypted and secured to the ultimate destination. So your answer is yes. Indigo and the protocol space at large supports a rich set of intermediaries.
Could you say a word or two about the relationship between Indigo and ASP.NET?
Okay, the question is the relationship between ASP.NET and Indigo. ASP.NET is the name of a bunch of things. If you think of ASP.NET as the IIS system, IIS is in Longhorn is being factored into pieces. One of them is called WAS, which is the Windows Activation Service, and you'll be able to activate Indigo within WAS. WAS supports activation on an extensible set of protocols. So you'll be able to install an Indigo service into IIS and then activate it across any of the protocols that we support. If you want to write your own transport, you can also plug it into WAS, and so you could do SMTP activation of an Indigo service and the like. ASP.NET is also a programming model. You will be able to host aspects in the Indigo pipeline, losing the features that come out of the pipeline, and you'll be able to, we intend to be the next generation at ASIMX, and so ASIMX programmers should find clean interop with Indigo and an easy migration of code that doesn't become too HTTP specific. So our team owns ASIMX, and we work hard with Scott Guthrie's ASP.NET team, and so they're one of our cousin teams, and so that is all part of the picture. One more question, and then we have to let Dr. Khan say the more practical part of the talk.
Could you say a little more on service-oriented programming? I still struggle to see any difference there other than that you're using the web service standards. You glossed over it somewhat briefly. Can you explain what's different about the paradigm here?
Sure. So there are a bunch of people who have specific sets of tenets or rules of what service orientation is. And I'm a practical guy, so I'm not the sort of person that would argue for one to the other. It's the idea that matters. If you compare service orientation with object orientation, what are the big differences? First off, services aren't coupled by type, which objects are. Services are coupled by contract and by schema. And so all of the coupling between a service, one and the other endpoint in a service can be represented by a contract, whereas that's not so in object orientation. And the wins there in terms of versioning and interop are clear. But it's not just interop. I think versioning is the more important thing there. I can evolve one side of a service without redeploying the other, which I can't do in a strict object-oriented system. The second big difference is policy. Typically, object-oriented systems have a specific transport mechanism and encoding that they use. Service orientation depends cleanly on being able to have an explicit specification of the transport, encoding, and protocols by means of policy that can be inspected by machines. The third difference is autonomy or loose coupling. A service tends to be much more loosely coupled from an object than the client. You're doing more than specifying you don't understand the boundary. You're also saying you're not assuming that you're on the same machine or built in the same language or even built against the same runtime. So those kind of prescriptions make it more like, you get more decoupling in services than you get in objects. And the fourth is explicitness of boundary, and by boundary I don't just mean statements about the actual interface, where objects obviously are explicit about boundary, but also statements about shared resources in the environment. It's much more difficult to build a service that knows, there's a file on their machine that we're both using than it is to build two objects that tunnel through to each other through shared memory or the like. So those are all tenets that we came to by looking at people's experience building distributed apps. If someone had a different set of service-oriented tenets, I wouldn't argue with them. But broadly speaking, in an experiential way, people have all sort of trouble building distributed apps with an object-oriented system. We haven't made a lot of luck with .NET remoting in our world or object-oriented databases. So getting back to messages and schemas is a better decoupling.
Just a quick, do you have any white paper that articulates the set of principles?
Yeah, so Don Box, you go look up 4 tenets Don Box on the web and you'll find it. Don Box, 4 tenets of service orientation. It's on MSDN, but Google is a good indexing mechanism.
Steve, could you switch me over, please? Because I can't figure it out.
Okay.
Oh, it died on me. Yeah. Thanks, Steve. After Steve's excellent introduction to Indigo, I'm going to talk about application of Indigo, talk about our system or series of systems we have been designing and building at Ohio State Medical Center. This is a long talk, but I'm not going to go through all the slides. The slides will be up on the website. So I'll just skim through the slides and just tell you the things which are related to our work. And most of the technology type of talks, Steve has already introduced them to you, so I won't make you go through them. So my name is Farouk Khan, and I'm in 2 different colleges and 3 different departments, and there's absolutely no politics going on anywhere. We are the OSU Buckeyes. Go Bucks! Is there anyone from Michigan here? Oh, excellent. Okay, we have a large team. I've got about 11 to 12 graduate students working on this. This is a team from the College of Engineering. From the College of Medicine, we have also another large team, but a different type of team. Here we more have administrators, nurses, equipment managers, director of anesthesia, so on, because we need a lot of support from OSU Medical Center, which doesn't have any politics there either. So it all started with about 3 years ago when we got this gift based from Microsoft Research. And in those days, web services, WYSI, which later on turned into WYSI Web Services Enhancements, they were known as GXA. And we submitted a proposal, and we got real good funding from Microsoft. And I also want to thank Dan Fay from Microsoft, who has been helping us all the time, and also got him ready. Is he here? He's academic developer relations. He's doing an excellent job of supporting us. Okay, in the last 2 to 3 years, our work has had really good success, and we have had publications. Typically, we are having 1 publication a month, This month we are going to have Computer World. They're doing a major article on our work. So we have some nice publicity going on here. Okay, the whole aim is the dream of people working in the health science, IT people, is the electronic medical record. And it's well known that since there are so many errors in the medical field, a lot of them are human errors, and these errors can be eliminated if we use an electronic record. But there are a lot of factors which are stopping us from using electronic medical records: standardization, security, data entry, integration, policy, and also other big, large, important things. For instance, if you just have an electronic medical record that's within your hospital or medical center, it's not going to stay there forever. It has to leave. It will go to insurance companies, or it'll go to another hospital. So you have to be able to have your medical records. So you have to be able to have systems which interoperate with other systems. In other words, you have to have integration between hospitals and insurance companies and hospitals. And that's a very big thing, because you can make your medical records which follow certain type of security, some proprietary security and privacy within your enterprise, but as soon as it goes out, you have a big problem. Therefore, it's really very important for us to stick to standards. Here's the OSU Medical Center. It's highly ranked, state-of-the-art wireless connectivity. You can judge the size of a medical center by looking at the operating rooms. It has this system has 50+ operating rooms. It's a huge hospital. And most of our work is done for the operating room complex. In other words, the vital signs within the operating rooms, patient tracking around the operating rooms, medications given in the medical room, pharmacy aspects, and other things related to the operating centers. Okay, one of the systems we built, one of the first systems we built using web services and WS-AtomicTransaction, and now we have almost converted into Indigo, is centered around an operating room. So I'd like to show you a heart transplant procedure going on. And before our system went into effect, I'll show you what kind of system was being used. Basically, here's an anesthesiologist, and behind this blue curtain is the patient. And here are some transducers. They're all connected to the patient, and they're measuring things like ECG, blood pressure, cardiac output, etc. And these all appear on this monitor. And the anesthesiologist uses this very high-tech paper pad and high-tech pen and marks everything diligently down after every 5 minutes. And these are the infusion pumps where medication is pumped, and that's also marked over here. And that turns into an anesthesia record. So obviously, such systems have lots of problems. For one thing, in the heat of the operating room, when you have to do many things, sometimes things are not marked down, medications are not marked down, and then they're forgotten. These medications are very high narcotics. They're extremely expensive. Even, these have to be saved and audited and everything drop by drop. And this paper record then turns into a huge stack, and then it's just stored somewhere, and there's no correlation between medication given and the vital signs. The vital signs which are appearing over here are just recorded over here. So you cannot data mine it. You cannot use this data for educational purposes or for research purposes or training purposes. It just sits there in stacks. So one of our first jobs, the system we had to build, was to first of all take these vital signs which are appearing here, coming from the patient, so that you can see them anywhere in the hospital or even outside the hospital in a completely secure way. And number two, to be able to come up with some correlation scheme with all these different things going on in a hospital, so that we can study cause and effect relationships. So this was roughly what, about 2 years ago, the hospital administration came to us and asked us to come in and look at this problem. One of the reasons why I think our system is so successful is that we did a very thorough domain analysis. As a matter of fact, we did more than 4 months of domain analysis. And that's something you can only do in a university. Okay, we had something like 10 PhD students spending morning up till evenings for 4 months in an operating room or the environments. And that's in industry that would be a very expensive thing to do. But something in a university, you can do something like this. And we took our time and we spent 4 hours there. We did a very comprehensive workflow of the medical center and the operating room environments. We basically, these 4 months paid off later on. During those 4 months, we discovered lots of shortcomings, which I've already mentioned. Vital signs monitoring constrained to ORs. Data collection lacks fine granularity. It's done every 5 minutes. Paper-based, you cannot do any correlations. It's hard to track patients. Patients can get lost. In 50 operating rooms, you have got a buffering system. You have got rooms where patients go before. You have got rooms where patients go later, or some patients go to intensive care units, surgical intensive care units. And so with so many patients moving around, it's natural to understand that without an automatic system, some patients will get lost. Equipment gets lost. Surgeons borrow equipment. Anesthesiologists borrow equipment from one room, take it to another room. At the end of the operation, they leave. The equipment is still there. So we're also doing patient and equipment tracking. So one of the things we came up with was the concept of a medical action. Basically, anything of medical relevance that happens to a patient or happens to an equipment, happen to an operating room, is a medical action. So we have vital signs action. So all the vital signs, heart rate, cardiac, etc., associated with one patient, we call it a medical action. Medication action is when a medication is given. Position actions could be when patient is moved around, patient enters an operating room, that's a position action. When equipment enters a room, that's an action. Similarly, there could be radiology actions and other type of actions. Then records are nothing else but taking collections of actions, okay? So a patient record is you collect all the actions associated with a patient. That turns into a patient record. An anesthesia record would be all the collections of the vital signs as well as the medications. So what you saw the anesthesiologist writing down on that pad would be, in these terms, would just be a collection of vital signs actions and medication actions. So in the same way, we can have OR record, equipment records. Then we can view everything on a timeline. So the whole concept then is to, actually these two labels are interchanged. So for example, okay, so here's a timeline, and each one of these green things is a vital signs. So that's the patient is connected to a monitor, and vital signs are coming out, and so each one of these are vital signs. This is a location action. This would be a patient going into a room. This would be a monitor going into a room. Okay, and then we have general clients which read these which look at these timelines, and the general clients to look at any type of action. So for example, you can look into an operating room and you can follow it this way. And our system then can record all these actions. They go into a database. They can be replayed later on. So you can replay a whole operation later on. You can look at this, and you can do this from anywhere in the hospital, in the cafeteria, in the office, or from home. Or you can do it while you're driving your Lexus. Goals, you could actually see it on the screen over there. Okay, so the goals were to improve operational efficiency, automation, so on. You can read these goals later if you want to. But we were able to meet these goals quite well. The high-level requirements were, again, loosely coupled, wanted to secure for the hospital, we wanted to be very highly available and very highly scalable. Hundreds of clients would be using this system, or approaching 1,000. By the way, the system is a production system. It's not a demo or anything like this. It has to be scalable, maintainable. That was a very big thing. We should be able to collaborate with other hospitals. OSU Hospital has very strong collaboration with Children's Hospital, so we should be able to look into their operating rooms. They should be able to look into ours. And we should be able to do this even though we have different security policies. And we've got different types of policies, but we should still be able to interoperate. And that's where technologies like Indigo come in and solve these problems. Standard-based, which Indigo is platform agnostic. Not centrally controlled, but a federation, self-healing. So based on that, without any when we did the analysis, we had no preconceived idea about what system we are going to build or what technologies we are going to use. But after that, slowly we discovered that web services, SOAP web services would be a very good fit, would be an ideal way to mimic the systems in the hospital, pharmacies, and different things. And now our system has really mushroomed. Each one of these blocks you see is a collection of web services and other types of services. What you are seeing here is the system which was built using WYSI before Indigo. And within each one of these blocks, we use many different technologies. We used web services. Then we have messaging queues in there. Then we have NT services. And we have got enterprise services. So to make the system really decoupled, we had to come up with many different services. And one neat thing about Indigo is that it provides you only one programming model. So now, instead of having 4 or 5 different technologies and different programming models in each one of these boxes, we have got only one programming model. And that's how come our life got tremendously simplified when we switched over to Indigo. By the way, this system is about 90% being Indigoized. Within 2 weeks, we should have the whole system running in Indigo. Okay. The ORI is the system where you look into the operating rooms and you look at the vital signs. OR Track is the system which you're building for patient tracking and other tracking. This tells you the web services which are there in ORI. We can look at the system and using different types of smart devices, pocket PCs. We have different types of clients. We have smart clients. We even have macromedia clients. Since web services are completely interoperable, we have no problem talking with different types. One of the things, the hospital uses WebSphere, and they're interoperating with us. And our vital signs go to them, and then they use our vital signs for billing purposes and other things. So it's very easy to interoperate with our system. That's just a high-level view. This shows you that in order to build a really decoupled and robust system using web services, you cannot just use core web services. You have to use many different technologies. And what Indigo has done is made this so that you don't have to change your programming model. By just tweaking little buttons and knobs, you can make Indigo do different things. And before, you would have to completely change over to a completely different model. For example, enterprise services and web services were like orthogonal to each other in the old days. That just tells you that if you just want secure conversation, you're really using the standards WS Security, WS Trust, WS Policy, WS Secure Conversation. And behind the scenes, okay, you just send a message. This is, again, a slide from WYSI, but Indigo does, I don't know similar, but does things like this too. And behind the scenes, you have got a lot of stuff that is built in the infrastructure, which we don't have to do anymore. In the old days, we would have to sit down and build all this infrastructure. But this infrastructure is already part of the is part of the whole thing. Okay, so the benefits of using WYSI before we move to Indigo is we got a very clear separation between security and other security concerns and our business logic. They got completely separated, cleanly separated. And a lot of security concerns were automatically taken care of by the infrastructure. So in our last project, we spent about 80% of our time dealing with security. And in this project, we spent only 4% of our time on security. So basically, security is completely sitting there ready for you to use. And moving over to Indigo, you don't only get security, you also will get reliable messaging. You'll get all sorts of different transports you can use. You'll get atomic transactions and many other things. This shows you our ORI desktop client, a smart client, and this client interacts with all the web services in the background. And currently, now it is interacting with Indigo web services. What you are seeing here is the timeline. You're seeing it in the archive mode, where things have already been recorded, and you're replaying an operation. And in this replaying of an operation, this needle is moving over the vital signs I showed you. Here's a medication action. Down here, as the needle moves up there, you see the vital signs down here, and you see all the other things. By the way, the -32768 is when no monitor is connected there. And we put in there no monitor connected or something like this, but the anesthesiologist complained because their own machine showed -32768 in red. So we had to go back and put this in. So okay, but when we used WYSI, even though we've saved 80% of the code, we still had these problems because we're building a very complicated near real-time web service system. We were using different data models, XML schema. Okay, we were using all our modeling in XML schema. It was very complicated. There was no versioning in XML schema. That was a problem. The schema was not published in WSDL, so they had to be moved out of the band. That was another problem. There was no way to explicitly do SOAP faults. So we had to do our own proprietary way of sending faults from the service to the client. We didn't have any RM, so we had to build our own pseudo RM. We didn't have any typeless routers, and with the Indigo, we have been able to build some typeless routers, which have enhanced our scalability by a huge amount. And these are routers at the SOAP level. Okay, these are also the complexity of multiple modes and tools was there, and the learning curve was fairly steep when we were doing WYSI. I have another slide which basically says that when going to Indigo, we have overcome all these problems. There's no need to show that slide. Basically, all these problems have been taken care of. This is just our Indigo mini system, which we built earlier, but now our whole system is almost turned into Indigo. We have built in now versioning in the system. We have got, instead of doing a lot of XML, we have gone more into data contracts, remaining into CLR. And that has a very big advantage for us. Our vital signs data contract look like this instead of looking like this. And so we don't have to go to two different tool sets, one for XML, one for CLR. We basically are now sticking to CLR, writing CLR classes. Okay, everything else I have told you. That's just scalability. This is all our tracking system. I don't have time to go into this, but the tracking system is also is entirely being written in Indigo, and it's plugging into everything else. Everything is like building blocks. Things are plugging well, and everything is scalable. And here are the benefits of our system, and you could ask any question you can in the next 5 minutes. Yeah.
Can you give us an example of a security fault program here?
Okay. When we were doing WYSI, we had to mess around a lot with policies. In Indigo, Indigo is taking care of the policy for us. So we are not writing it, we are just using different profiles that come with it.
So what kind of policies does Indigo develop for you?
When you use, in this case, well, for example, what's the real question?
Please give us an example of a security policy that Indigo provides for you.
Okay.
That you don't have to worry about.
Okay, for example, the policy, we are going to use X509 certificates, or we are going to use Kerberos on this side, or we are going to use transport level security here, things like this.
Hi, Dr. Khan. I have two questions. The first is, back here.
Yeah.
The granularity is good, but now you have all this data. What are your plans for where do you
Okay, that's a very good question.
So,
we have got lots of data, and the data is going into this. That's our next thing we are going to work on. We need some data mining over there and visualization. So I'm talking with some people in our computer science, in the high performance department, and computer science, and that's where we're thinking about how to visualize this data, how to data mine this, and things like this. So right now, it's just going into this big bucket.
And the second question is, the medical industry has been notorious for not adopting technology very quickly.
Exactly.
What has been your experience and the rate of adoption of this technology?
You're right. It's very difficult to. The medical industry is very, very tough to put technology in there. You're right. But in this case, we basically approached it from inside. I'm a part of the Department of Anesthesiology, and so the 4 months we spent in doing domain analysis also helped us a lot, because we talked with people, we made friendships, and we said that these are the kind of things that will improve your life. And so we were able to, we didn't have such a big problem into putting these technologies in, but in general, it would be a problem. If you approach it from the top down, it would be a bigger problem than if you approach it from the department level and anesthesiologists themselves saying, we need a system like this. So basically, that's how we approached it. Could I talk to you? I'll talk to you later about policy and things.
I'm not sure I quite understood where Wi-Fi fitted into your whole system.
Okay.
Could you comment on that, please?
Yeah, the Wi-Fi is for tracking purposes. What we are doing is using existing Wi-Fi infrastructure in the hospital to track. So basically what you do is you get the signal strengths from the access points, and from there you figure out where you are. But if you do it in a simple way, it's very noisy. You have to use hidden Markov models and things like this, and so you can figure out where you are based on the access points that are already there.
So within your system, it's purely for location tracking then?
Exactly. Yeah. No more questions? Thank you.